Um,
Yeah, okay, so today we'll be talking about probability. Um, so
okay,
we want to
literally
make
get
sure
off.
to,
Okay, there. Sorry, Sonia, go.
we want to make sure that everyone understands our cheat sheet, and we're just going to go over it briefly, since we don't want to like read over them. But this will be a good refresher for people who don't like probability or just don't get it as of right now. So I'm going to start, and let's start with some probability. Okay. So probability is simply how likely something is to happen. So whenever we're unsure about the outcome of an event, we can talk about the probabilities of certain outcomes, how likely they are. So the analysis of events are governed by probabilities called statistics, where the other group will be talking about. But the best example to understand probability is probably just flipping a coin. That was one of the first things we learned. And, there's two possible outcomes, right? There's heads or tails. So, what's the probability of the coin landing on heads? It's something that's like basic, but you might intuitively know that the likelihood is half and half or 50%. But there's another way of looking at this is using the actual like rule that they have, which is number of ways it can happen divided by total number of outcomes. But as you can see here, there's some, P of A, probability of A. That's what it means. So um, that's kind of the notation of everything. So P of A equals number of ways A can happen divided by total number of outcomes. And that's where we get that. Next, we have complementary events. And it's just two events are said to be complementary when one event occurs if and only if the other does not. So um, the two complementary events add up to one. And there is right over here, if you look at it, there's an easy explanation there too. But rolling a die is something that's easy to understand for this concept. So for example, rolling a 5 or greater or rolling a 4 or less on a die are complementary events because a roll of 5 or greater, if and only if it is not 4 or less, that's what it is. So the probability of rolling a 5 or greater is 2/6, right? So that simplifies to 1/3. And the probability of rolling a 4 or less is 4/6, and that simplifies to 2/3. Thus, the total of their probabilities, if you add those together, so 1/3 plus 2/3 equals 3/3, which is 1, which is why we have, that rule there. So you can always use that rule. Next, combined events and mutually exclusive events. So these are kind of simplified where combined events really just overlap when drawn in a Venn diagram. If you guys remember those Venn diagrams, can you zoom in? Yeah. So we have these examples here. For if you're using this cheat sheet digitally, it's going to be easier to look at, but it's basically saying hearts and kings are not mutually exclusive. It can be both. So over here, you can take a look at how this Venn diagram intersects. And then mutually exclusive, on the other hand, is events that do not overlap. So as you can see here, aces and kings are mutually exclusive. It can't be both.
But don't okay, this is just a random question, but isn't like don't you also have to include the like the other numbers for probability, like the numbers outside of aces and kings?
Yeah, so for combined events and mutually exclusive, those are just simple examples for looking at it on the Venn diagram, but definitely there is something that's outside and that's inside, and we'll focus that throughout the example part of the presentation. Thank you. And then can you scroll? Yeah, okay. And then finally, we have conditional probabilities. Okay, so when you are given additional information, so that when given B, you calculate the probability of A. So in other words, you find the probability of having A out of B, and that's what conditional is, and that's the rule too. and you use the tree diagrams. And we'll practice that more with Delta Math, and we have a worksheet available too, so we can take a moment to just work on those examples. And then independent events, so they are, they do not change the probability when other event changes. So example here is landing on heads after tossing a coin and rolling a 5 on a single 6-sided die is an independent event because it doesn't change it doesn't change the probability when the other event changes in this case.
Okay.
So we have expectation and variance. I know a lot of people might remember this. It's an easy formula to understand, I think, but we'll get into it for Isabella's part on the right. But expected value or mean of a binomial distribution is calculated by multiplying the number of trials, which is n, by the probability of successes. For example, if the expected value of a number of heads in 100 trials, so 100 trials would be doing this of head and tails is 50, you would do 100 times 0.5, which is just the 50. And that's how you would find that. While the variance of a binomial distribution is this formula over here. And so if we're looking back at our example, when P is 0.5, the distribution is symmetric around the mean.
Okay. So next we have the random variables, which is a quantity whose variables depends on chance. So that would be going along with a lot of Sonia's examples, like flipping a coin or rolling a die, like something where it's like it's not a weighted die, it just kind of like depends on luck or fate, whatever you want to call it. That's just a quick definition to keep in mind. Now, we have probability distribution on the table. In my opinion, this was one of the easier parts of probability because here they say Px, big X equals little x, which equals 1. And you have this variable W, but they have a constant in front of each W. And you basically, this notation here means that all of these things added up in this bottom row equal 1, if you recall. So you would just write it out like a normal equation and then solve, and that'll get you W. Now the expected value is the average value you would get if you were to repeatedly measure the variable an infinite number of times. So that's like, essentially if you were to add the number over and over and over again, you would basically just use this formula. This little notation means standard deviation. So it's basically the sum of sample times the probability of the random value. So an example of this, it's usually used within a chart like this again, is a 6-sided die is thrown and you can see 5 sides. Let's say it's a 1, 3, 3, 4, and 7. What side landed on the table of the expected value is 5. So basically here, you know that this notation again means that this equals 5. And so basically an easier way to do this is you would just because you don't know a variable in the top row this time, you would just take the 1 and multiply it by 1/6 plus 3 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 7 times 1/6 plus W times 1/6 equals 5. And again, you would just solve that like a normal equation, and that gives you W equals 1. Next, we have regression. Regression, again, in my opinion, was one of the easier parts of this unit. It's a function that best approximates a collection of random data. It can be a linear equation. It could be representing a quadratic regression or an exponential. So this is these are the calculator steps to seeing a regression, just in case you guys forget when you go to practice. So you would press the stat button and then edit. Then you would input the data, whatever the set of data that they give you is. And then you'd press stat, and then you would move to calc, and then you would choose the function, whether that be linear, quadratic, or exponential. And the R² is the coefficient that determines the regression. It's between -1 and 1. It represents this, that's what represents the strength of the regression. So if you recall, there should be a section on Delta Math about this. But that's basically like the negative one is like the perfect negative regression, and then the positive one is the perfect positive regression. The 0 would be no correlation. And then we have this strong negative where it's like they're kind of scattered, but they still have a negative slope. And then the weak negative, where it's like you can kind of tell it's negative, but they're pretty scattered. And the same goes for the weak and strong positive, just in the opposite direction. So if you don't feel strong on this, or you think you need a refresher, Ms. Thompson's posted Delta Math. The Delta Math combines both probability and statistics, but I would just look specifically at the regression section.
We all love binomial distribution. No, all right. So binomial distribution, there's different types of distributions that we've kind of put in this cheat sheet to remember. So for binomial distribution, it's basically it's probability that summarizes the likelihood that a value will take one or two independent values under a given set of like parameters. So the underlying parameters of the binomial distribution are that there is only one outcome for each trial, that each trial has the same probability of success, and that each trial is mutually exclusive or independent of each other. And those are keywords that are in the top table, so that's good. So you can take a look here. The binomial distribution is given by this equation, and everything is annotated here to understand this. Yeah, but it applies that events are, success. So that's one of the examples. And we'll give you calculator steps for this, but there's binomial PDF and CDF, which are different in the case of like using your calculator and what you have in a problem. So for PDF, it's a probability that there will be like X success in N trials if there is a probability of P of success for trials. So, so I will send you a link to how to use your calculator for this. But then on the other hand, CDF, it's exactly the same as the PDF, except that instead of a specific number of successes, so when I say successes, I mean like trials, like different trials. So you have 3 trials. That's going to be what you put in your calculator. But on CDF, this function gives you the probability that there will be 0 to X successes in the N portion. This is difficult to like explain as of right now, but in an example, it will be more like understandable just to practice this.
Yeah, I would say for the types of distribution, because we go over normal distribution in a minute, but just like as a side note, this is kind of more of the stuff where like you're probably going to have to go on Delta Math and like on our worksheet and like practice on your own, because it's a lot of it is honestly just remembering how to work the calculator.
Mm-hmm.
So yeah.
Can you go to your normal?
Yeah, what I thought. Okay, so now we have normal distribution. So standard deviation, it's pretty self-explanatory, but it's basically how far away something is from like the middle or the mean. So like as we can see in these pictures here, like this is like 12,000, that's like right in the middle, so that's the mean, and then like each space is like 50 plus or minus 50 away from that. So everything is based around this 12,000 right here. So we have 2 types of standard deviation. There's population standard deviation, which is like the entire set of data. And again, in Delta Math, there's a section where you can practice this, and it's pretty simple. Like it won't be to the level that IB would test you, but I think it's really good to like refresh how to work the calculator, because that's really important in probability, especially for this second page of our cheat sheet. So this would be the little symbol. This little O means like population standard deviation. and the x represents like the distance or the space. And then we have the sample standard deviation, which is reflecting like it's in the name, it reflects a sample size, a small portion of the population, but it's not necessarily the entire set of data. So for cumulative, and the representation for that would be SX, which means sample standard deviation. So a way to remember that would be like SX equals sample. So like connecting the S and the S, that would be the way to remember that. And then this little symbol kind of looks like an inverted P, like a sideways P a little bit. That's how I remember it. So the cumulative distribution function, this is just the calculator steps right here for like how to do normal CDF and PDF. The rules that apply for like when you use normal PDF versus CDF are the same in binomial as it is in normal. So basically you just press this button, I can't remember what that stands for, but you press that and then you press second vars and then you just go to normal CDF. And then this would be the order that you put things in. You use CDF when there's a range of trials or successes. So like lower, upper, and then you put the mean, and then you put the standard deviation. So we don't know why we wrote commas above the 7. Sonia and I tried to figure it out for like an hour last night, so just disregard that it says that. I don't know what that means. But so let's say that for a normal CDF problem, they just gave you like, we're doing 3 trials, like that's not a range. So you would use normal PDF in that case, and there would be no lower or upper. It would just be number of trials, which is 3, and then you'd put the mean, which in this example down here is 12,000, and then you'd put the standard deviation, which is 50. Pretty self-explanatory. So if it says number less than, like let's say the problem, I'm pretty sure I have, let me go to the notes. Let's see. So let's say that the problem right here, let's say that the problem doesn't necessarily give you a super specific range. Like let's say it says the amount of time a certain brand of light bulb lasts is normally distributed with a mean of 12,000 hours and a standard deviation of 50 hours. What percentage light bulb lasts less than 180 hours? So you know it's a range because it says less than, but it's like, what's the lower end of the range? Because all they give you is the 1,080 hours. So when it says less than, you know your lower bound or your lower boundary is going to be negative 999,999. And if it was the opposite, if it said more than, your lower bound would become 1,080 and your upper bound would be positive 999,999. So like just to recall that, because that I know that can be a little tricky to remember. And then finally we have z-score, which is how many standard deviations something is away from the mean. So the z-score would be the data minus the mean divided by the standard deviation. So we have an example right here, and I also put that in the notes, I believe, right here. So on a standardized exam, the scores are normally distributed with a mean of 300, so we can see that's in the middle, and a standard deviation of 25, which would be below. Find the z-score of a person who scored 265 on the exam. So basically a person who scored 265. So what you would do is the data is 265, so that's your x, and then the mean, the thing right in the middle, is 300, and then the standard deviation, how far away something is from the 300, is divided by 25. So for this you end up getting the negative z-score of 1.4. So the z-score, as long as you can remember this formula, but more importantly what it stands for, you should be in good shape. And then the very last part of our cheat sheet is using standard deviation to find the mean. So this is an example from Delta Math, and we pull examples from Delta Math. With distribution, Delta Math would be really good because they give a lot of examples of normal distribution particularly. So this example of standard deviation to find the mean says, on a normal test, that has a normal distribution, a score of 40 falls 3 standard deviations above the mean, and a score of 32 falls 1 standard deviation below the mean. So one good way to do this would be to draw out a number. So let's just put your mean right in the middle. You know that 40 is 3 spaces above, and 32 is 1 space below the mean. So everything is centered around the mean. You don't know what it is, but you know that it's there. So if 32 and 40, you would, once you draw this number line, you would pieces apart these two variables are. So you go 1, 2, 3, 4. Okay, they're 4 spaces away. So 4 minus 32 divided by 4, which is 8 minus 4, which equals 2. That's how you find your standard deviation. So now that you know your standard deviation, you go, so if 32 is just 1 space below the mean, and it's only, everything is plus or minus 2, would be 34. So that's how you would use the standard deviation to find the mean. It's basically working backwards from this, where around here they give you the mean, here they don't. So that's pretty much it.
You forgot the inverse norm.
We have, oh, right, my bad. Hold on. Just kidding, there's one last thing. Fun. Okay, go sorry.
So we have inverse norm. Now she did talk about just normal distribution, but there's inverse. So there's a way to work backwards from a known probability to find an X value. And basically to be like, we had to research this more in depth, but it's actually an informal term and it doesn't really refer to a particular probability distribution, but there is an example over here, and I would like everyone to take their calculator out to try this example. And everyone good? Okay. So these are the steps for the calculator. For this example specifically, we were supposed to sketch a distribution and label, and then mark where your given percentage would fall. But Isabella kind of showed how to do that. But the basic is you, especially for Leonard and I's calculator, we just have to do, you just press the inverse norm, which is the same for everyone's calculator, so that's good. Inverse norm, and then you see that there's probability, mean, and then standard deviation that is part of it. So distribution, and then second variable, and then you can go forward and then check if your data point makes sense. So for this example, Isabella, can you like scroll, like not scroll, I keep saying scroll, zoom in for a bit?
Yeah, on the example?
Yeah, on the example. See, over here it gives you the mean, 80 beats, so that you're good with that, what's given. And then you got a standard deviation, it said 9 beats per minute. This is a simple example, but it says the school nurse plans to provide additional screening to students whose resting pulse rates are in the top 30% of the students who are tested. Okay. And so it says top. So over here, it's going to be max is 70% and min is 30. Because what we did to get the 70, first of all, is you have this 100%, correct? And it says top 30%. So then 100 minus the 30 equals that 70. And when you put it in the calculator, you don't put just 70%. You don't just put 70. You put 0.7, because you can't really put a percentage in this calculator for that to work. So you put 0.7, and then 80 and the 9 that is given to you. And then your final answer will just be 84.7 BPM and 3 significant digits. And that's how you go through this example, which will make more sense as we go through the worksheet.
Sonia, did you go on, was it math? And then can you go back to, like, 'cause I didn't get that.
Yeah, here. So for our calculator, you press the second,
Mhm.
like, you know how there's here. Let me show you on. So you press that little second button first, and then you go to vars. Above it, it says the
Okay.
distance.
And then I go to norm. Oh,
You,
inverse norm.
Yeah.
yeah, you would just press inverse norm, and then you would enter when it says area. That's basically like what we did with this max of 70% and minimum of 30.
Mhm.
That Sonia explained. So there you would just type in 0.7 because you have to remember we're dealing with percentages. So those aren't like actual values. So you have to convert it to that
It
decimal.
says tail, so should I put center, left, or right?
It says what?
It says tail. I don't know.
Can you show me your calculator?
Hers is talking about the left tail, right tail thing.
Oh.
So this example is where it's the left tail, I'm pretty sure.
Okay.
Remember, left tail, like, you technically could have done it, I think, Jacqueline, if you had done right tail, you could have just left the 0.3 and you wouldn't have had to do the 100 minus. But some of the calculators don't have that capability
Okay.
to
Well,
do left tail, right tail.
I got the same answer.
So is your
Okay.
area 0.3?
Yeah.
0.7.
It depends
no,
on if
your
you're
area-
doing left. It depends on if you're doing left tail or right tail. Like, think of the
Okay.
whole bell curve as that's like 1,
Mhm.
and then the top is 0.3, so that would be the right tail.
Okay.
Like, and then the other side would be if you do 0.7.
Okay.
So it just depends on which setting you're using.
So if you do right tail, you can do 0.3.
Yes, I think so. And
Yeah,
you should
just
get the same
remember.
answer.
Yeah, I mean, like, my calculator doesn't do that, but like it says top 30%. So that would be your key that like that's like actually like that's like in the top within that top 30.
Okay.
So then the other part would have to be 70.
Okay, I don't. Is it 84.7? Okay, cool.
So that's our review over this probability cheat sheet. Obviously, this is not enough, but I would advise for everyone to first work on Delta Math just to get some basics down with your calculator, as Isabella said, and other, Z-score and all that lovely stuff. And then we will send you the worksheet. And that worksheet does have a key at the bottom, so you can check yourselves as well. All right. How's everyone feeling about probability?
Actually, I mean, I don't exactly remember all the little logistics and little things, but I remember probability being one of the ones that I understood well, with like the trees and like the formulas and everything.
That's good.
I have a lot to review, let me put it that way. That was one of the units I did not get at all. So I'm still going to go over this about a gazillion times.
You
Same
did
here.
good job.
Mikkel, are you singing?
I'm just reading